So we have the objective, which you should have already written down. So for 4.6, we're talking about medians of a triangle. So our objective is to find the medians and the centroid of a triangle. So hopefully you already have that in your notes. Our second page is your homework answers. I'd like for you to take a second and check your homework.
Which one, the paper or this?
It's the bookwork.
All right.
Okay, so I'm going to highlight what we need in each of these. There's 2 vocab words that are going to go on your vocab sheets. The first one is the median of a triangle. So that is what's bolded. So the median of a triangle is a segment from the vertex to the midpoint of the opposite side. The next page is going to have 3 examples that are going to go into that draw box on your page. Our other word is going to be the centroid of a triangle, and this is the point where all 3 medians intersect. So I will draw that off to the side, and then on the next slide there will be a picture of a median. So right here, where they all 3 intersect, that's your centroid. Let's rewrite that. So our theorem is the intersection of medians of a triangle. So the medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. What is a vertex? Mario?
It's like a point, like main point or something like that.
So when you're saying point, are you talking about like here? Or are you talking about like
Like at the top.
So like here?
Yeah.
So each of these are going to be vertexes. So a vertex is where the 2 sides of your triangle meet. So yes, you're correct for that. So all 3 of them are technically a vertex. So this is at the bottom of your guided notes page. This page has pictures of medians. So this goes back on your definitions page. Can I borrow this, Willie? So on your definition page, where it says median of a triangle, it has that draw box. I'd like you to draw these. So these are just 3 different medians being drawn in a triangle. You see this one starts from this vertex and goes down. It intersects the base of this triangle and puts it into 2 congruent, or splits it into 2 congruent segments. And you see that by the tick marks. This one comes from the right vertex. It intersects. Again, we see 2 congruent segments. It has the double tick marks. And over here, it's the left vertex intersects. It's going to bisect that one again. And we see that those 2 segments are going to be congruent. The third one here, where it says, or the fourth one, in triangle ABC, draw the median. We're going to do that. There's not actually a spot for that on your examples, and I apologize. I drew mine next to my vocab. So in the vocab section, I drew that next to it on my guided notes. So we're starting at vertex A, and we're going to draw that median to the opposite side. When we draw it to that opposite side, it's going to bisect that segment. So it's going to bisect BC. So when we bisect it, we're forming 2 congruent segments. So we're going to want to try to eyeball it, because I'm not going to give you guys rulers for this, to make it look congruent. Then we're going to dash, or put the dash mark in, tick mark, and then we're going to say how much each side has to be. So starting at A, I'm going to bisect BC. So that looks like it's approximately halfway through, or at least it did. And then I'm going to draw my tick marks in to show that they are 2 congruent segments. And now that I see that they're 2 congruent segments, what length do those segments have to be? They have to be 7, because it's half of the length we have. So half of 14 is 7. So we're going to put 7 on each of them. And so for this one, that's all that I'm going to ask you to do. Okay, so once again, we're going to draw that median from our vertex of angle A. And we are going to have it go down. And when we draw that median, it bisects the segment opposite of the angle. So I'm going to have you guys draw these triangles, and then we will perform these operations. Okay, so we're drawing these medians starting at angle A, and we're going to bisect the segment opposite. So we're going to start at angle A. We're going to bisect again. I'm just going to ask you guys to eye it since we are not going to actually use our rulers, which we could do. Measure it out, divide it in half, put our median, connect it from the vertex. And then you're going to denote that they're congruent by our tick marks. If they're congruent, what length do we have to have them in this case?
13.
It's going to have to be 13 because it's half of 26. So each of these has to be a length of 13 for it to be bisected. So we're going to do the same thing on the next one. And the next one, we're going to start again at angle A. And we're going to bisect the segment opposite of it to draw that median. I'm actually going to erase that. We'll try it again. Hopefully yours went better than mine did. So angle A. Oh, sadness. Twice. One more time. Third time's a charm. Can't handle it. Is yours guys? Well, you're not drawing on an iPad.
I'll draw for you.
There we go.
I like to draw.
I'm happy to hear that. Okay, we have two congruent segments. Hopefully yours looks slightly better than mine because mine's a little off center. And when we have that and we bisect it, and we're bisecting 6, how big are each of the lengths? 3. Okay, our next one, Willie's already jumped to. So once again, we're drawing that median starting at angle A. It's going to bisect the side opposite of it. And then, Willie, what are the lengths of this one once it's bisected? 5 and 5. And then the last one, starting at angle A again, bisect the segment opposite of it. And so it's going to be 10. Nice job, guys. Okay. So we have the intersection of medians of a triangle, which is what we just talked about. You guys wrote it down at the beginning. So you no longer have to write this down because you already did. But we have symbols. So the book teaches it this way using these symbols. I have decided not to teach it using the fractions. There's another way to do it. So I'm going to draw it onto the page, and I'm going to ask that you guys copy it down so that way we're avoiding fractions, okay? So the way we're going to do this is our first part of our triangle, so the distance from the vertex to the centroid, so where all the lines are intersecting, we're going to make that a distance of 2x. So on this one, they're talking about AD, so we're going to have this, and so this is going to be 2x, because it's starting at the vertex, and it's going to our centroid. From our centroid to the part where it intersects the segment opposite, or the side opposite, that distance is going to be x. So on these problems, we're going to set it up as the whole length of the segment, so that distance from A to D. Remember, when we talk about distance of a segment, we do not put a line over it, equals the distance from A to P plus the distance from P to D to get that total distance. And then we use the fact that we know AD equals, we see here that this is a distance of 2x, and PD is a distance of x. And so we are going to use those facts to solve these, avoiding using fractions. Okay, so our next group, this is an example based on the way the book does it. So I'm going to talk to you guys about how the book does it, and then we'll talk about our method. So we do it avoiding the fractions, but if you're doing the book method, it actually has the formula from the last sheet, and you see that the distance KP, which is from the vertex to the centroid, is going to be 2/3 of the total distance. So you just take 2/3 times the total distance, you set it equal, and then you solve for the other one knowing the total distance, subtract what you found, and then you solve for the other one. So what we're looking for when we do it is we're going to use that same line, that Kn equals Kp plus Pn. So I'm going to write that over here. So Kn, the total segment, equals the distance from Kp plus Pn. Okay, we know that the part of that segment from the centroid to the vertex is the 2x portion. So we have 2x. I drew mine in. I think that it's helpful if you do. The part that is from the centroid to the part that bisects the segment is going to be x. So when I rewrite this, I know that Kn equals 2x plus x. We have a value for Kn. I could have written that in instead of running Kn the second time. What value do we have for Kn? It's 18. So I have 18 equals 2x plus x, which is 3x, thank you. Divide by 3. X equals 6. Yep. So now that we have that, we're going to solve for the two parts. So we're interested in Kp. Our Kp we know is that 2x. So Kp equals 2x. X is what value? It's 6. So the value has to be 12. And then Pn is just x. And we know x is 6. So we end up with 6 and 12. If we add them back together, we see that we get what they arrived at, 18. So again, this method gets us away from using those fractions in case you're not a fan. So again, we are now going to solve these three. And we are going to set it up just like we did in that last example. So we want to find the distance of BD. So BD is the total distance of this median. And so we're going to write that out using those symbols. So we have BD equals BP plus PD. So this is that total, I'm sorry?
You skipped the slide.
Did I?
Yeah, you
Oh, I'm sorry. Give me 1 second. We'll pause here. I'll go back to the other one.
BP equals BP.
One here. And then that's the one we're on. Okay. So take a second and write these down and we'll get started. Okay, so sorry about that. Let's start again. So now we are looking for the distance of AP. So we'll find AP. So that's this distance here. And PD. And we're using the fact that we know the distance of AD. So we're going to write this out. So AD equals AP plus PD. We know the distance from the vertex to the centroid is 2x. So I'm going to draw that into my picture. And we know from PD it's going to be x. So on each of these, the part from the vertex to the centroid is going to be that 2x. From the centroid to the side opposite of the vertex is going to be just that x. I'm going to fill in what I know. I know the distance of AD is what value? It's the distance of AD is?
60.
It's 60. And so 60 equals, AP is 2x, like you said, and PD is? We're going to combine our like terms. So 2x plus x is?
3x.
3x. We want to solve for x. So I'm going to divide by 3. When I divide by 3, what value of x do I get?
X equals
20. Nice job. Now we want to find those two values. So we're interested in the distance of AP. AP equals 2x. We know the value of x, which is? So that equals 40. And our last one is PD. And that value is x. And we know the value of x is? 20.
Where does the 3 come from?
So where does the 3 come from?
3x.
So we get 3x because we have 2x plus 1x.
Oh.
Where did we get 2x from?
We have 2x from that last slide where we talked about how when we set these up, the distance from the vertex to the centroid is going to be a 2x distance, and the distance from the centroid to the side opposite that's bisecting is going to be x. So that's based on us using a formula.
So what is the answer?
So our answer here is the distance of AP equals 40, and the distance of PD equals 20. If we add these two together, we see we arrive back at that whole distance of AD, which is 60. Our next one, we're going to set up the exact same way. I'm now going to switch my colors so you guys can see a different problem. And here we want to find the distance of HP and PG, given that HG is 36. So I have HG equals GP plus PH. Again, which segment's going to have the distance of 2x? GP will, because it's the one starting with that vertex, yes. So I'm going to draw that in, 2x. So that means that PH has to be x. We're going to take what we know and substitute it into the equation we just formed. HG is what value? 36. GP is 2x plus x. We add together our x's, combine our like terms. We get 36 equals 3x divided by 3. X equals? Not 22, not yet. 12. So now that we have x equals 12, we're going to solve for GP and pH. So GP equals that 2x. We're going to solve or substitute in our x. So 2 times 12, which is 24. And then we have pH, which is just that x, and that's just going to be 12. So we arrive at those two distances. If we wanted to justify this or verify this, we would see that 12 plus 24 equals 36, which is that total length of our median. And we have one more problem like this. I'd like for you to take a second and set this up on your own.
All right, I think I can do that.
I believe in you. Okay, Jaheim, do you want to set up
I
the...
did the first part and stuff, but
Okay. So you set up the first part, Willie?
yeah, I did the first part, but I don't know the last.
So how do you set up the first part?
Okay, with the first part, I put KM. Well, first I put X on the line with K and P.
Yes.
And then I put 2X on the line with the no, I think I flipped
You did
it.
the other way?
Yeah.
So let's take a second real quick. So remember when you do this, you have to have the part with the vertex to the centroid has to be the 2x.
Okay.
So that is common. So you're probably not the only one here who did it.
Okay, but I still did the.
You did the rest of the setup correct? Ready to go?
Okay,
So
I did
KM equals
MP plus PK.
plus PK. Did you all arrive at the same spot?
Yeah.
Okay, now we're going to substitute in what we know. Jaheim, you ready for this part? KM equals, what's MP? X. And PK is? 2x. We're going to combine like terms and insert what we know. We know KM is 99. 2x plus x? 3x. We're going to divide by 3.
X equals 33.
X equals 33. Nice job,
And
guys.
I'll do the rest.
So now to finish it up, what we're going to do is we're going to take the two formulas that we know. So if we're interested in KP, we know that KP is 2x. So we have KP equals 2x. We have 2 times 33. So KP equals 66. And then we have PM, which is equal to x, which is just going to be that 33. Nice teamwork. Okay, so
We get about here at 51.
52. So we have 3 minutes. I'm going to try my best to solve all 3 of these. So, yes, Randall? It's the same problem. Thank you for letting me know that. Okay, so our next ones, we're going to set this up. So now we want to find the distance of the total distance BD. So the way we're going to do that is we're going to set that up as BD equals BP plus PD.
What do you mean, BD?
Oh, I did it again.
Sure.
So which one do I have to change?
The equals. BP.
Where did the PD come from?
Oh,
Oh, I see.
Yeah, it's supposed to be BD.
BD. Thank you. Okay, now that we've set that up properly, I appreciate your help. We are now going to sub in what we know. So the distance from our vertex B to the centroid is going to be that 2x, and we know the value of it. And then our distance from P to D is going to be x. So we're just using what we know. We're going to substitute that in. So we know that BD equals 2x plus x. We can find out our value of x because 2x equals 8. We divide by 2. X equals 4. We're going to substitute that back in. So we have BD equals, we know the distance is going to be 2 times 4 plus 4. 8 plus 4 is? 12. So our distance of BD is going to be 12. We're going to set up the next one in the exact same manner. Now we are looking for the distance of EH. EH equals EP plus PH. We know the distance from the vertex to the centroid is going to be that 2x. The distance from the centroid to the other part is just going to be x, correct? We set that up as EH equals, we know the distance of the EP, so we have 2 equals 2x. X equals 1. We're going to sub that in to find EH. EH equals, 2 times 1 plus 1, which is going to give us 3. Nice job. And then our last one is we are interested in finding the distance of KM. KM equals KP plus PM. We want to find KM. We know this portion right here, please hold on guys, is 2x, and this is, we're going to substitute that in. So we have 2x plus x. We know that the 24 equals 2x. X equals 12. We're going to substitute that in. So we have 2 times 12 plus 12 is?
Hold on.
Yes, sir?
No, we can talk about it. You got a worksheet.
Equals 36. So today we talked about centroids and medians.
I have a question.